the regulations we currently have for aquatic invasive species. They were the things that got it started. They came into the Great Lakes separately in the late 80s and early 1990s, just as we had in California, separate introductions. So we got quagga mussels in our backyard in 2007 and zebra mussels just in our one site in 2008. So we know that they've had major impacts. I won't spend too much time on this because I think most people are aware of this. I mean, certainly in the Great Lakes and elsewhere, they've dramatically caused problems with water intake systems and water conveyance items. They clog pipes and have all sorts of other impacts as well. So lots and lots of industry and infrastructure consequences. This is just a quick view of what happens in places when they're really well established in the Great Lakes, millions of dollars a year on control just in one institution. So we're hoping that this doesn't happen in California. So of course, as you'll see, the goal is to contain the spread. There are impacts on ecosystems. You can see crayfish, mussels, benthos bottoms. So there's lots of things that can be heavily impacted by zebra mussel infestations. Lakes and shores, this is a view from the Great Lakes, but you can see something like this in Lake Mojave with shells littering the shoreline, creating hazards for beach walkers. So there's a lot of significant impacts of the species, one of which is just jokingly potential recreation hazards, so that's on a golf ball, but they do grow everywhere. Mussels in California have really occupied a lot of different locations. There's 43 documented by CDFW. This is, of course, their diagram, which clearly shows a recent northward spread into Ventura County in 2017. There haven't been any new sightings since that period last fall. And then, of course, no new zebra mussel sightings since really just the one or two, depending on how you slice it, in 2012 in San Benito County. And again, CDFW for more information about this. Now, CDFW has done a great job so far in trying to manage the spread of dracinid mussels. So there's new fish and game codes that mandate prevention programs. More than about 100 locations have watercraft inspection programs. Some employ dog inspections of mussel dogs to sniff out mussels. Even veligers. Whoops, what is going on? Hope that's not seeing anyone. Many activities are scheduled for this week. So the Invasive Species Awareness Week involved dog demonstrations, mussel demos. So this is sort of a nod to CDFW and their activities. So there's a little bit of salesmanship for them. You can see it on their webpage. So check out the activities for this week regarding zebra and quagga mussels. The point I want to make here is if you look here in this lower corner, this is where the current distribution, as USGS has, for quagga mussels in California. So there's much of this lower area of California. And I want to point out, though, that it's really small in proportion to what has been determined to be the distribution that could, the potential range of the species. You can see this red area here. This is a paper from a few years ago using some of their restrictions habitat-wise, but really we're still waiting for, or there's the potential for much of the rest of the state to be colonized by these guys. So this is really an important future threat. I'd like to touch on just a couple other invaders that are important in California, aquatic invaders. So in addition to quagga and zebra mussels, we've certainly had problems over the last decade or two with species like the Chinese mitten crab. It's come into San Francisco Bay in 1991, likely as a result of intentional introductions for market reasons. It's very valuable. It's had very costly impacts on water pump and fish salvage facilities in the early 2000s and late 1990s. We've had no new range extensions, however, since then. So the distribution has actually been quite stable since that period in 2005. The European green crab, another important invader that came in the late 89-90. It's had significant impacts initially, especially on manila crab fisheries and native systems. However, this species also, at least in California, has had no new range extensions since the late 90s. That's been also fairly static in its distribution. Some species that have continued to move are the New Zealand mud snail. So this is an important invasive species in river systems. It was introduced in 2001. It's now found throughout the state of California. It's had significant impacts on stream systems in other parts of the Intermountain West, and its range expansion continues throughout California and also in other areas of the Northwest as well. Some species that are continuing to expand and are have sort of thwarted small-scale attempts to control their species is the Japanese kelp, Daria pinnatifida, which is found in LA and was moved to Long Beach and Pillar Point in San Francisco. It was the focus of some small-scale eradication efforts that turned out not to be very effective or not successful. So it is continuing to increase its distribution. It certainly causes and can cause quite a lot of expense for harbors and marinas. As you can see, it's quite large. Another species that certainly had and is continuing to have impacts a little bit further offshore is the Sargassum horneri species. It's a species of sort of understory algae that's invaded kelp forests. It spread rapidly from Santa Barbara, started from Long Beach through Baja California, and now all the way up to Santa Barbara and the Channel Islands. This is, again, a species where the range expansion is still continuing. So again, a lot of these species are looking to move in bad directions, at least in expansive directions. I want to make the point, however, that managers, researchers, others, at least on small scales, have had success in controlling some of these invasive aquatic species in California. So these are San Francisco Bay or Southern California estuary species. You can see this brown algal Ascophyllum nodosum, that sort of brown stuff all over the rocks in a limited area, was entirely eradicated in San Francisco Bay early 2000s. Probably much less known than this more famous example of Caulerpa taxifolia, which was, of course, the killer algae that, with great expense and effort, was eradicated in Southern California, Agua Hedionda, and excuse me, one other bay in Southern California. Here you can see it. These were both successful eradications, and they have not returned to any real extent. One of the last points I want to make is that as we think about these species coming in, I want to make the point that it's not just sort of the usual mechanisms by which things come in. So it's not simply just by boats or sails. You can see this photo right, this pie diagram right here. A lot of these were historically stocked. Some have come in through aquarium releases and just hitchhiking with other species. Some cases, pets or bait releases. But the issue is there's a lot of ways in which these species come in, many of which are very addressable. So I think the future of this is that we have a real opportunity to try to thwart future introductions. We know what these pathways are. We just need to have the wherewithal and the political effort to be able to make headway and to stop species coming in via these pathways. I also want to make the point, this is again data from USGS, that it's not just from exotic places around the world. Enormous numbers of our introduced species are coming from other places in North America in many cases, or sort of places in the Pacific Basin. So we know what the origin of a lot of these species are. In many cases, it's really very close by and in our backyard. So we really need to be able to not just try to, when we can, eradicate these problem species, some of which, very few of which we've been able to, but we really need to put the clamps down and try to reduce the opportunity for invasion in the future. Okay, so what I do is just stop here. This is my contact information. I'm happy, again, to answer questions about any of these species at the question and answer period at the end of this talk. So I'm going to stop here, and I'm going to allow John to pick up and show you his talk. So he should be able to grab mine. I will stop sharing. There we go. John, take it away. This is John Madsen, who is a research biologist for USD ARS in Davis. Go ahead, John.
So, are you all seeing the presentation?
Yes.
Yes, we are.
Okay, good. Thank you. So I appreciate this opportunity to talk about aquatic invasive plants. I'm mostly going to highlight specific species, and I will note that algae are some of the invasive plants that we see in California. I'm not going to talk about any particular species of algae, though. So in natural waters, we really see invasive aquatic plants in virtually every type of habitat. We see them in lakes and reservoirs, and in rivers and streams, and in estuaries. And we see them in very pristine waters, and we see them in some, not so pristine waters. This is not an issue of cultural eutrophication or pollution, other than an introduction of an invasive plant species. And we also have invasive plant issues in irrigation canals, though many of our irrigation canal weeds are native plants that are not desired there, but some of them are in fact also invasive plants. And here are some examples of some irrigation systems, most notably the California Water Project. I don't have any pictures of the smaller feeder canals, but typically the problems are occurring in the feeder canals or the canals that supply these feeder canals, and not so much in the larger part of the system. And the impacts of these aquatic plants are very widespread, interfering with commercial and recreational navigation, hydropower generation, the transport of irrigation water, drinking water supplies, flood control, and so on and so forth. So they have a big economic impact in California. I also want to highlight that they have a significant ecological impact as well, degrading water quality, reducing species diversity of both native plants and aquatic animals. When we talk about aquatic plants, we tend to think of different growth forms, be it emergent plants like the picture in the upper right-hand side, floating leaf plants that are otherwise rooted, such as the next picture down in that vertical series, free-floating plants like the third picture there, submerged plants, the fourth picture, and then algae, and there are various types of algae. And these tend to distribute themselves by depth in water systems. So we typically see the emergent plants either in moist soil or in the shallowest portions of the water, followed by floating leaf plants and then submerged plants as we get deeper and deeper. And I do want to point out that we have a number of different mechanisms for managing these aquatic plants, and they include biological controls, chemical control, which would be herbicides, mechanical operations, and then physical operations where we alter the environment to reduce the growth of the plants. I'm not going to go into great detail on these management techniques. If you're really interested, you can contact me separately, and I can send you a book or two. But I do want to highlight some of the species that are having a big impact in California. The first is giant reed, Arundodonax. This is a very tall grass. That's actually an adult standing there in front of a 20-foot tall giant reed plant. The rhizomes are massive. They're the size of, well, the size of a leg of some people anyway. So they're very robust plant, and this has been a focus of control in California for a number of years. There are a number of strategies that are being followed for Arundo, including recently the release of a couple of insects that were found overseas. The second is Waterhyacinth, and this is a very significant weed problem in the California Delta, the Sacramento-San Joaquin River Delta. This is also the #1 aquatic weed worldwide. So this is a pretty significant weed species. And while it has very showy flowers and produces seeds, it's primarily reproduced by a vegetative process of of new plants formed on the end of stolons. And there are a number of methods of controlling this species as well. The third is that I'll mention is Brazilian waterweed, or Agaricus densa. This is a completely submerged plant. There's some pictures of the plant that's flowers. The flowers do come up above the surface. This is the dominant submerged aquatic plant pest in the Sacramento-San Joaquin River Delta, and this is one of the two targets when the Delta Smelt Restoration Project is talking about creating habitat. One of the species they want to get rid of is Brazilian waterweed. And again, there are a number of methods of controlling Agaricus, and I'd be glad to give you more information at some other time. A very recent invader is South American sponge plant. This, as far as I know, this is only found in California within the United States. And the State Department of Food and Agriculture has put this on the state noxious weed list, and they want to control this. This plant is found in a couple of locations. It's found in the Sacramento-San Joaquin River Delta, and I'm going to just start calling it the Delta now because I'm using up all my time saying Sacramento-San Joaquin River Delta. And again, there are a number of ways to control this species, but we know very little about the biology or the management of this species as yet. Water primrose is becoming a widespread problem, not only in California, but throughout the United States and worldwide, particularly in the temperate zone. And trying to put this into a single species is problematic. The taxonomy of water primrose is nothing short of dizzying. It's a mess of polyploids and hybridization and natives and non-natives, and it's a mess. So I just call it water primrose, or if I'm feeling really technical, I call it just Ludwigia, and leave it at that. And again, we can manage this by a number of different methods. Hydrilla is an interesting plant. This is nationwide, becoming a more and more of a invasive plant issue. In California, about 2 decades ago, the California Department of Food and Ag declared this a state noxious weed. They saw it as a threat to irrigation, which it is, and they managed to get it named a federal noxious weed, which usually doesn't happen to a widespread plant. And the state has done a fairly good job of eradicating hydrilla from most of the water bodies it was found in the state, but there are 1 or 2 persistent populations that they're still working on. And again, a number of different ways to control this species. I can't leave off Eurasian water milfoil because I've done a fair amount of work on Eurasian water milfoil. It's a very common invasive plant. It is not given any particular special status in the state in terms of being a noxious weed or other designation, but it is a widespread invasive aquatic plant. It's one of the species that they're targeting for concern in Lake Tahoe. It's in the Fall River and a number of other water bodies in the state. And again, we know how to control it if we can get an opportunity. Curly pondweed. I'm getting to the end of the list of species here, don't worry. This is a very interesting submerged aquatic plant. Again, this is in a number of water bodies in California and is of concern. One of the other species that they're concerned about in Lake Tahoe. This plant it has a very unusual life history in that it tends to die back in the summer and rest as a propagule we call a turion, and then it tends to come back in the fall. But that life history is moderated by water temperature. And again, we can control it by one of many different methods. So that's my discussion. I just wanted to talk about some of the species we have in the state, and I'd be glad to answer questions either at the end of this or if you want to send me an email or something separately, that also be okay. Now I'll turn it back to Ted.
I think we're going to go to Valerie at this point.
Okay.
Okay, are we seeing my screen?
Ted, did you want to give Valerie a quick introduction?
I can do that. So our next speaker, next presenter is Valerie Cook-Fletcher, who's a senior environmental supervisor at CDFW, who has lots of different projects going on and is now also shouldering the rapidly expanding Nutria program. So Valerie, tell us about this.
Okay, how are we doing volume-wise?
I think we're good.
Okay.
Sounds good to me. If anybody's having trouble, technical problems, hearing or anything, please do post that to the chat and we'll see what we can do.
Okay, so today I'm just going to talk a bit about the recent discovery of Nutria in California, a bit about the impacts and the management efforts in other locations in North America, what those implications are for California, and then just briefly touch on what the state is currently doing about the issue. So Nutria are large semi-aquatic rodents that reach about 20 pounds in size. They're native to South America. They were originally introduced to North America and specifically California in the early 1900s for the fur trade. So they were actually farmed in California in the 30s and 40s. And then following the collapse of that market, many of those animals were just released. So we ended up with feral populations of Nutria in California in the 50s and 60s. And then they were declared eradicated in the 70s. So there was some not well reported eradication effort back in the 60s and 70s. Then they were declared eradicated. Nutria, as you can see, are very similar in appearance to our other native aquatic mammals. So I'm going to try to get crafty here with this laser pointer. Can you guys see that laser? Maybe? Okay, so on the bottom left.
Took a minute to unmute.
Okay, so the photo on the bottom left, from left to right, is a beaver, which reaches anywhere from 40 to as much as 70 pounds in a large adult. Next to that is an adult nutria, which this has a frostbitten stubtail, so typically a bit longer than that, followed by a groundhog, which we do not have in California, and then a muskrat on the right, which has a maximum size of about 5 pounds. So those are about the size of roughly a football. So you can see there's a lot of overlap in appearance between particularly in overlapping size classes like juvenile beavers and adult nutria and juvenile nutria and adult muskrats. So the distinguishing characteristics that we're urging people to look for are those long white whiskers. So nutria and sometimes beavers and muskrats can all have those white muzzles, but it's those long white whiskers that are a distinguishing characteristic of nutria, as well as that long, round, nearly hairless tail. So beavers obviously have that wide, flattened tail. Muskrat tails are sort of wedge-shaped. They use that for serpentine movement when they're swimming, while nutria just have that long, round, hairless tail that just sort of trails behind when they swim. So this flyer on the right is a resource that we put together for the public and for landowners to help distinguish nutria from other similarly appearing mammals in California. So a bit about their biology and ecology. Nutria are reproductive by about 4 to 6 months of age. So they are rodents. They reproduce quickly and many. We're seeing early maturation in California around 4 months of age. We're seeing breeding occur. They can produce up to 3 litters in 13 months, and litter size can be as many as 13. So you can imagine that population sizes add up pretty quickly. They live in social groups, so those typically consist of a dominant male, several reproducing females, and their juveniles. As those juveniles begin to mature, they're driven out or dispersed as far as 50 miles from their family group. So you can imagine that, you know, they can increase both their population size and their geographic distribution very quickly. Though average home range size for nutria is typically less than 25 acres, we do see daily movements. Telemetry studies have shown daily movements of 2 to as far as 6 miles from their den. So when we have detections in California, we have a bit of investigating to do to determine whether or not that animal belongs to a social group that's there in the vicinity, or if this is a dispersing animal, or an animal that's just out venturing, you know, 2 to 6 miles from their den. They inhabit both freshwater and brackish habitats. So, you know, we're all aware of the complex nature of the Delta and its tributaries. And so far we're seeing them in streams, managed wetlands, sloughs, rivers, oxbows, ponds, and they are now up into the legal Delta as well. So there's a lot at stake as in terms of California's waterways. Nutria are most well known for their herbivory damage. So they are herbivores that consume up to 25% of their body weight each day. So for a 20-pound animal, that's 5 pounds of vegetation each day that they're consuming, but they're really destructive and wasteful feeders. So they can destroy as much as 10 times as the amount they consume. So again, a 20-pound animal might consume 5 pounds of vegetation in a day. In that consumption, they might be wasting up to 50 pounds per day. They really strongly prefer the basal portions of emergent vegetation, like you'll see the capsule pictures off the left side of the screen. They really like those submerged and basal portions of those plants. So often they'll go in and eat the submerged portion and dig up and eat the basal portions, the roots and tubers of those plants, which then leads to loss of our soil organic matter and severe soil erosion as well. Nutria also consume ag crops. So, you know, our waterways are adjacent to a good deal of agriculture through the state. So those adjacent ag crops are also at risk of consumption. Other states have also reported exacerbated invasive plant infestations due to nutria herbivory damage. Texas reports that Arundo donax has been fed on and damaged, and then send fragments downstream in the river systems that then lead to exacerbated populations downstream. I did actually just receive a photo from DBW, Parks Division of Boating and Waterways, that treats those aquatic plants in the Delta and its tributaries of a nutria in the Merced River system out in the middle of a large mat of Waterhyacinth and parrot feather. So if we start seeing herbivory damage and fragmentation on those plants, that's just going to make our jobs that much harder. But in terms of soil erosion, long-term impacts can result in conversion to open water. So the photo on the bottom right is Blackwater National Wildlife Refuge up in the Chesapeake Bay. The 1939 photo is prior to nutria introduction. And then by the 80s, they had lost over 50% of their marsh habitat due to nutria herbivory and that loss of those wetland soils. Another impact that nutria are notorious for is their burrowing damages. They don't build lodges like beavers. They burrow into vertical dirt banks. So that has some serious implications for California's water conveyance and flood protection infrastructure, our river banks, our levee systems. We talked about those animals living in colonies. So they're building these dens for multiple animals, and they can be very complex, multi-level, as far as 18 feet deep, and can extend over or up to 150 feet into a bank. So California really is sitting at sort of this trifecta of impacts in terms of our agriculture and our canals and irrigation systems, our river systems, our flood protection levees, our water conveyance networks, as well as our wetlands and our Pacific Flyway. California really has a lot at stake here with the impacts that nutria cause. So here I want to talk a little bit about what impacts have been documented in other states that are infested with nutria. Louisiana is one of the more notorious situations. Similar case, nutria were introduced in Louisiana in the 30s. They started observing impacts in the 50s, but nothing was done or evaluated until the 90s, at which point I think they had seen population estimates as high as up in the millions. In 2002, they received funding and were able to implement control efforts, but by that point they had determined that the only feasible approach to controlling this population was an incentive program because the population was so large. So they implemented a bounty program which paid $5 a tail for up to 400,000 animals a year. So since 2002, they have paid out over $24 million for over 5 million nutria harvested just through the bounty program alone, and that's just for maintenance control. That does not include all of the nutria that are shot off of their levees by the state, and does not include the money spent on mitigating damages. So these photos in the bottom are just a good example of what nutria herbivory does to marsh habitats. That's a photo of an exclosure that prevents nutria herbivory. So you can see the extreme loss of that marsh vegetation and soils. On the flip side of things is the Chesapeake Bay Nutria Eradication Project. Again, it's a similar story. Nutria were introduced in the 40s, started noticing damage in the 50s. Harsh winters knocked the populations down in the 70s, followed by a population boom in the 80s. Then they start really noticing the impacts and received funding from the Fish and Wildlife Service to evaluate whether or not eradication was feasible. So this effort was on the Delmarva Peninsula, which is surrounded by ocean on 3 sides. They implemented eradication in 2000, and since that time they have removed over 14,000 nutria and have not had a single detection in over 3 years now. The photos on the bottom show pre-nutria removal on the left, followed by passive recovery 1 year post-nutria eradication at that site. So what's going on in California? The initial discovery was in Merced County in a managed wetland in March of 2017. Since that time, we've had, as of yesterday, over 110 nutria taken in the state. Those are juveniles, adults, males, females, pregnant females. They've been detected in 6 counties, San Joaquin, Stanislaus, Merced, Fresno, Tuolumne, and Mariposa counties. And they've been found on federal, state, and private lands. Of those 110 animals that have been taken, nearly all of those have been in Merced County, but they are through the San Joaquin River system up as far as Old and Middle Rivers, and are confirmed in the Merced River system as well. It's important to note, though, that a good deal of these reports and confirmed locations are incidentally reported to us. This is not a comprehensive picture of the true extent of this infestation. This is just the information that we have so far. So though they are now detected within the legal delta boundary, we're not definitively saying that this is as far north as they have gone. And so we also talked about that 50-mile dispersal distance from their social groups. So when we put down a 50-mile buffer here and we look at the true extent of the water and the hydrologic connectivity in California, we're talking about a lot of water and a lot at stake here in California when we look at the dispersal potential of these animals in the populations as they continue to reproduce. Population control. I want to talk a little bit about what we do and do not have working in our favor in California. In their native range, which is southern South America, they're preyed on by large cats, so jaguars and ocelots, as well as caiman, and they're hunted as a food source. Yes, that photo is not from Argentina. I couldn't find an Argentinian hunter, so this is well representing Louisiana. Also in Louisiana is their bounty program. They have, as I mentioned before, up to 400,000 animals each year. They're also preyed on by alligators, gar, fishes, and cottonmouths. Mortality in Louisiana is very high at 60 to 80%, yet they still have populations in several hundred thousand. In the Chesapeake Bay, their populations were really well controlled or inhibited by their severe winters. So those extreme temperatures cause mortality in both juveniles and adults, but also reduce reproductive output. So can cause females to resorb or abort partial or entire litters. So those severe winters really inhibited population size in the Chesapeake. Obviously, that's not something we're dealing with here in California. They also have their eradication program, their trappers in place, and also report that nutria there, as well as in Washington, are preyed on by large birds of prey. In California, though, as far as large cats go, I don't know how many mountain lions we have out roaming the marshes, but I can assure you it's not enough to control this population. The photo in the center is a game cam video of a bobcat and a nutria standoff at a bait pile. That bobcat gave up and wanted nothing to do with the nutria. It's a fairly tense standoff that the bobcat chose to walk away from. And then lastly, coyotes. This was from a series of photos where the coyotes did get a hold of the nutria a few different times and they tangled up pretty good, but in the end, the nutria got away. So we don't know how viable of an option that's going to be as a predator-prey relationship. So long story short, we don't have as much working in our favor in California as they do in the native range and these other locations where population sizes have still been very large. This is a visual representation of the trend in an invasive species population from its point of introduction. So as an invasive species is introduced, as time moves on, the area infested and the total population size increase. There's sort of a lag phase, and then as the population is allowed to persist longer and longer, we start to see exponential growth in the population. And then eventually the population size and the total area infested is too large for eradication to be an option, and you get to the point of local control and management only, and all the while control costs are getting more and more expensive and less efficient. So we believe Louisiana is sort of on the top red end of that curve where local control and management is their only option. We believe that the Chesapeake Bay project was somewhere in the middle of that curve when they got started, and knock on wood, we hope that California is still down in the lag phase where eradication is still feasible if we get on this with adequate resources quickly. So what are we doing in California? As of March 2018, CDFW redirected resources and staff from a few of its regions to form survey and trapping teams that are now deployed out on the ground. We're in an incident command system. We've been working pretty closely with the Chesapeake Bay Nutria Eradication Project to look pretty closely at what they have done successfully and what lessons they've learned. We're working on a contract with Wildlife Services to bring in some expert trappers to the project. We're pursuing and have received a few grants to get the project going as we work towards establishing long-term stable funding for the project. So we've received a Delta Conservancy Prop 1 grant, a Wildlife Conservation Board grant, tentatively received a state wildlife grant, as well as an Aquatic Nuisance Species Task Force grant. So both state and federal grants are contributing to getting this project off the ground until we obtain long-term adequate funding. But the major needs that this project needs right now is access to private properties. So we're pursuing temporary entry permits so that our survey and trapping teams can get out on the ground and determine the full extent of the infestation and deploy trappers to those infestations. We also need to promote public awareness of the nutria issue, identification of animals and sign, and promote reporting of sign and nutria taken by landowners. So nutria are classified as a non-game mammal in California, which means they landowners and their agents have the authority to take those animals for the protection of their property. However, they are not they're not a game or a fur-bearing mammal, so they cannot be legally taken under a hunting license unless you are the landowner or an agent. And so with that, I want to point you to the website hyperlinked here, wildlife.ca.gov/nutria. This is a resource we've put together for the public that has the flyer for identifying nutria, a landowner flyer, letting people know what we need to come out and do and how they can help. There's a draft version of a temporary entry permit that can be used to provide us access to your properties. And then there's also always the most up-to-date map and information about county detections, as well as a great deal of photos of nutria damage and sign and what to be on the lookout for in the field. And with that, I think we can open it up to questions for the panelists.
Hi, Valerie and Ted and John. Thank you so much for your presentations. I'm going to actually launch a quick poll. I'll open it for about 3 minutes. For you guys who are attending, we'd love to get some feedback from you. And while we do that, I think you guys can still hear everything. First, I just wanted to mention to the folks who are on the phone, I posted this in the chat, but after a final okay from all of our presenters, I'll give them a chance to do that. We will post these presentations back to the Invasive Species Lunch website. And I will also add any specific links that the presenters presented or want to send me, like this link to the Nutria page, to that website as well. And with that, I will direct you guys to a couple of questions here. Oh, whoops, indeed. I apologize. I am sorry. I am going to end this poll and launch another poll. Sorry about that. Thank you. And I'm sorry if you answered the first couple of questions. If you could re-answer them, that would be really, really helpful for us. Thank you so much. This is the correct poll here for the aquatic invasive species. Thank you, Marcy Sousa, for pointing that out to me. And with that, let's see, go through some of the questions here. So D. Lombard has asked, Ludwigia has been completely controlled by naturally invading Altica beetles at Lake, hopefully I'm going to pronounce this right, Cumaye in San Diego. Are there any similar experiences elsewhere in California? I guess this is a question for John and Ted, but Valerie, if you want to weigh in, that's fine too.
Well, I'll jump in on that question. This is John Madsen. I'm with USDA ARS, and our group includes some biocontrol people. We've not either seen any of this impact from this beetle on Ludwigia, and we're not currently pursuing any biocontrol agents on Ludwigia, in part because the taxonomy right now is so messed up that it's hard to figure out, well, where do we go overseas to find insects that could potentially be used for control. We are working on biocontrol agents for giant reed and for Waterhyacinth, we had a program looking at some insects for Agarria, but they were not effective. So that's kind of where we're at with the biocontrol at this point in time.
John, just a side question. This is Ted, if you can hear me. Are you familiar with this Altica beetle?
No, I'm not familiar. If it was an herbicide name, I might be more familiar with it. But
Yeah.
Okay, and it looks like some of the other questions that have come up are more about nutria. Valerie, hope you're still listening in here. Good.
Yes.
And you guys can read these too. We only have a few questions, so I'm just reading them off. How do nutria's feeding habits compare to beavers?
Nutria are strictly herbivorous in that they prefer those sort of the submersed portions of emergent vegetation. And they really like to go for the basal portions of those plants in like the roots and the tubers. So they're really going for those below ground vegetation more so than the above ground vegetation. And they also do not, they don't go for woody vegetation so much.
Okay. Oh, sorry, in sharing my screen, I lost the chat. Here we go. Oh, nope. All right, I'm going to stop sharing for a minute. The reason that I shared, well, I'll go back to that in a minute.
What about that second wave that person asks about too?
Thank you for asking that. I can't apparently see the chat while I'm sharing my screen, so I'll leave it here for now. Yeah, where's the second wave of nutria believed to have come from?
That's believed to be a reintroduction. Early on, there was some speculation about whether or not this population was a result of just isolated remnant populations up in some pretty isolated areas. But at this point, we are very confident that this was an intentional reintroduction. For most of us ecologists, that doesn't make an awful lot of sense in terms of, why that would seem like a logical decision. But, with a few of the inquiries we've had about whether or not we'll pay bounties, or can people hunt them for recreation, or can people bring in their sport dogs to come and hunt them for recreation with their dogs, we're confident that this is a reintroduction and that we're in the early stages of that lag phase.
Okay, thank you. If anybody else would like to take the poll, that would be great. I'm going to guess the folks who have been taking the poll are finished now. If there's a few more of you who can, that would be great. I don't know if I can move it out of my own way at least. I did want to mention that, again, this is part of a series, and tomorrow you will be hearing from me as well as my co-presenters, Matthew Brooks with the Western Ecological Research Center of USGS, who does a lot of work on invasive species and fire in desert areas, Katie Van Zant, who's a botanist with the U.S. Forest Service, Angeles National Forest, who's done a lot of work controlling invasive weeds post-fire, and then I'll be talking about keeping invasive plants out of home, landscaped, and wildlife urban interface areas. So we hope you can join us again tomorrow. And I want to thank all of you for joining us today. And with that, Ted, did you have anything else that you wanted to?
No, just thank you to Sabrina for helping to organize this, and to Abby for helping to facilitate this.
No problem. All right, I'm officially closing the poll, and I'm not seeing any additional questions. So thank you so much, everyone, and hope to see you virtually again tomorrow. Thanks so much to Valerie and John, as well as Ted, of course. All right.